3. What about F? C to the 7th. That's okay. G, 2 to the 0. H, X to the 0. I. Yeah, I'll talk about it. It's fine. If you put 1, it's fine. 5 to the negative 2. Okay, good. So we have 3 different types of answers that we got in step 1. We got some that had a positive exponent, some that had a negative exponent, and some that have a 0 exponent. So tell me what letters had a positive exponent. F, what else? 2 more. What? A, not B. 2, no. A, F, and I. Okay. Which letters had negative exponents? What else? E and D. And which ones had 0 exponents? G, H, and C. Good. How can I tell what type of exponent will result simply by looking at the expression? How can I tell when I'm going to have a positive exponent? Explain. Exactly. If the numerator is greater than the denominator, then I'm going to have a positive exponent. When am I going to have a negative exponent? Yeah, if the numerator is smaller than the denominator. And when will I have a 0 exponent? When they are equal. Okay. All right, so we are going to take all of our negative exponents and we're going to look at them a little bit more to understand what that means when we have a negative exponent. So I'm going to look at B, J, E, and D. B, J, E, and D. So B, E, J, D. Okay, and I want to write each of these in expanded form. So B was 3 squared over 3 to the 4th. How do I write that in expanded form? That's the same thing as what I have.
3 times 3 divided by 3 times 2 times 3. Or times 3. I don't know.
This is it. Yes. 3 times 3 over 3 times 3 times 3 times 3. And what did we decide last week? What does 3 over 3 equal? 1. Right? So if I have a 3 in the top and a 3 in the bottom, they cancel out to be 1. 3 in the top, 3 in the bottom, they cancel out to be 1. But what's 1 times 1?
No, and then there's 2 left.
Ah, yes, there's 2 left. Yes. Right, 2 left. In the denominator or numerator? Denominator. So I've got 3 squared in my denominator. What's left in the numerator? 0? 2? Where'd you get 2 from? But are they, is this a plus sign in between them? What's 1 times 1?
1 plus 1.
So 1 is in the numerator. Just like when we have something like this, 3x equals 9, and we solve for x. It's not that these 3's cancel out to be 0, and this is 0x, it's 1x. Okay, so my answer is 1 over 3 squared. What did we say our answer was in step 1 for letter D? What? 3 to the negative 2. So what we just discovered is that 3 to the negative 2 is the same thing as 1 over 3 squared. Let's look at another example. Look at part E. I've got x cubed over x to the 6th. So that's x times x times x divided by x times x times x times x times x times x. And when I have the same thing in my numerator and denominator, they cancel out to be 1. So those cancel out, those cancel out, those cancel out. What's left in the denominator? Not 3x, but x cubed, right? And then what's left in my numerator? 1. And what was the answer we came up with for part E in step 1? X to the negative 3. So I just found out that x to the negative 3 is the same thing as 1 over x cubed. Okay, let's look at J. What was it? 5 cubed over 5 to the 5th. So 5 times 5 times 5 over 5 times 5 times 5 times 5 times 5. Kyla just, oh no, you just got back. I thought she just left. Okay, I've got 5 in the top, 5 in the bottom. 5 in the top, 5 in the bottom. 5 in the top, 5 in the bottom. What's left over in the top? 1. What's left over in the bottom? 5 to the 2nd power. Yes, we found out that that's the same thing as 5 to the negative 2. Okay, last one we'll look at is D. What was D? 2 to the 1st over 2 to the 5th. So 2 over 2 times 2 times 2 times 2 times 2. I just have one set of 2's that cancel out. What's left over in the top? And what's left over in the bottom? And what did we come up with for part D in step 1? 2 to the negative 4th. So we just found out 2 to the negative 4th is the same thing as 1 over 2 to the 4th. Do you guys see a pattern? Huh? Yeah, we specifically looked at all the ones with negative exponents. So what happened when I took my negative exponent and I transformed it into this other version? It became a positive and we turned it into a fraction, right? So that's what happens with negative exponents. The negative exponent turns it into a fraction. Okay, the other way I'm going to explain it is the negative exponent sends the base to the opposite place. And I'll explain what I mean, because these negatives are kind of funky. Okay, so let's recall that any number, even a whole number, can be written as a fraction. How do I write 2 as a fraction? 2 over 1. So you agree if you just see 2, then that's in the numerator, right? Even if there's nothing underneath it, even if it's not a fraction, it's still in the numerator, right? So when I take 2 and I raise it to the negative 4, like I did here, it takes the base and sends it to the opposite place. It moves it from the numerator down to the denominator. The exponent stays the same, it just changes from negative to positive. Let me show you another one. So if I have 8 to the negative third power, that's like 8 to the negative third over 1. That negative 3 as an exponent takes the base and sends it to the opposite place. So this becomes, my 8 moves to the denominator. Exponent stays the same, just changes signs. And then I have like a 1 on top. Okay, and the same thing goes if I start with a negative in the denominator. If I have 1 over 3 to the negative 2, that negative 2 takes the base and sends it to the opposite place. So it becomes just 3 squared. Okay? It's kind of weird. It's especially difficult to like verbally explain it. You know what I mean? But once you kind of get the pattern of it, it's really not that bad. I think so too. Yeah. Okay, let's look at step 5 really quick together, please. And I want to explain why this is true. Why anything raised to the 0 power is always 1. So can you tell me which letter in step 1 resulted in a 0 exponent? C. Let's look at C. That was 7 to the 4th over 7 to the 4th. I'm not going to do all of them. I'm just going to do one. I think it's enough. No, so 7 to the 4th over 7 to the negative 4th would be 7 to the 4th, and then this negative 4 takes the 7 and moves it to the opposite place, would be 7 to the 4th times 7 to the 4th. So you're right, it would be 7 to the 8th. Does that make sense? Okay. But here we have 7 to the 4th over 7 to the 4th. So that's 7 times 7 times 7 times 7 over 7 times 7 times 7 times 7. What happens with the 7 in the top and the 7 in the bottom? Cancel out to be what? 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 1. 7 over 7 cancels out to be 1. 7 over 7 cancels out to be 1. 7 over 7, 1. What's 1 times 1 times 1 times 1? 1. Right? And you see that would always be the same no matter what it was. If you have the same exponent in the top and the bottom, you're going to just end up with that 1. Okay? Clear? All right. What I want you to do is work on step 7, and step 8. When you finish 7 and 8, I want you to start working on the other side of the paper. Step 7, you're doing A, B, and C. And actually, step 8, I'm going to have you do it on a sticky note. So I'm going to pass out sticky notes for step 8. Sticky note. Okay, but A, B, and C, I want you to do on your paper. I'm coming around and grading those. And then I want you to start working on the back on sections A, B, and C. Then we're going to finish the back tomorrow.